Good day viewers, you are welcome to today's smart class. So today's videos will be talking about what we call set. So what do we mean by set? Set is the collection. Set is the collection of well-defined objects. So set is the collection of well-defined objects, and set is written in capital letter, and also all what is in it is called the element of set, and they are written in lower class, that is smaller letters. And I want you to know that all these elements are enclosed by what we call this curly bracket. Is enclosed by this curly bracket, which is this. So it is enclosed by this curly bracket. Now let's talk about the types of set. We have the universal set. Firstly, number one, we have the universal set. So now what do we mean by the universal set? This is the mother of all sets, and it is written in the form. This is the symbol to represent it, or we write this. So this is the symbol to represent the universal set. Now, for instance, we have, let me give an example. X such that X is the total number of students in the class, in the school. So now we are giving this and say such that the total number of students in the school, and we have set A to be all art students, B to be equals all commercial students, and C equals all science students. So let's explain what happens. This column like it here, we call it, you can call it such that. So I said universal set such that S is the total number of all sets. You can see that X, this universal set, it is containing set A, set B, and set C. Because all students, all of our students, they are students in the school. All commercial students are students in the school. All science students are students in the school. So we said the universal set is the mother of all sets. Now let's talk about the empty or void sets. So we have empty or void sets, and this is denoted. It is denoted by this symbol or just the curly bracket. It's nothing missing. So if you want to represent empty or void sets, you write it in this form. For instance now, if you say that X equals to Y such that Y is the JSS1 student and also the principal. How will a JSS1 student also be the principal of the school? That's the first question. This is not possible. Therefore, since you can't have in JSS one student will also be the principal, therefore you can just represent it with this symbol of null, this symbol of empty or void set, or you can even write it by saying or null set. Now, also we have the subset. For instance, now let's look at this question we use here. I wrote here now. We can say that A is a subset of the universal set, and you will write that in the form. You want to say that A is a subset of the universal set. It is written in this form: A is a subset of universal set. The reason why I said that, A said that here we have S such that S is the total number of students in the school, and for A we have all our students. Don't forget, all our students are students in the school, all commercial students are students in the school, all science students are students in the school. Therefore, B is also a subset of the universal set, and also C is the subset of the universal set. Okay, and also you can write it in the form by saying the universal set contains A. You can write it in this form also. You can do the same to this. Anyhow you write it, you are correct. So this is the subset. Why this one means the universal set contains A. So what other type of set we have? We have the singleton set. Now let's start with it. The singleton set. Now we are talking about this set now. For instance, now let's say that A S such that S is the principal of the school. So this type of subset contains only one element. That is, consider that B, in your curly brackets you have an element 2. So it contains only one element. Now, you know that in a school you have only one principal. Therefore, it is called a singleton set because it only contains only one element. Now we have what we call number 5. We have what we call finite set. When we talk about finite, the spelling for it, finite. I don't know whether my pronunciation is correct, but you understand what I mean. Finite sets are countable sets. So that's the definition. They are countable sets. Now, for instance, now you write that S, which is the set S, such that Y such that Y is the total governor in Nigeria. Don't forget, you can easily count the number of governors in Nigeria since you have 36 states. Therefore, we are going to have 36 governors. And the answer is F equals bracket 86. So this is called finite set. So you can count the number of sets. It is a countable set. But the opposite of this is infinite. This means they are uncountable. So uncountable sets. That's infinite. And for instance, now you have S bracket, you call it brackets, and you have D such that D is a real number. is an integer. Is an integer. Don't forget, integers are not start from what? 1, 2, 3, and so on to infinity. So we say that this is the finite set, and the definition says finite set are they are uncountable. Definition says they are uncountable. Therefore, you can't count the numbers of integers. 1, 2, 3, 4, 5, 7, 8, 9, 10, and so on. Or you just that you count the numbers of you count the whole numbers. They are also uncountable. So we call it finite set. Also, we have there's what we call cardinality set. Cardinality. Sorry for my pronunciation. So there's what we call the cardinality set. When we talk about the cardinality set, for instance, now you have x is such that y is such that y. Sorry. For instance, now in set x you have the elements of a, b, c, d. How many elements are here? We have 1, 2, 3, 4. We have 4 elements. Therefore, you just write it as n x into bracket is equals to 4. So now, when we are talking about cardinality set, it's talking about the numbers of the element set or the member set. The numbers, that's the definition. Numbers of total elements. So let's write it as total elements. Total or numbers of elements in the set. Numbers of elements in the set. So the numbers of elements in the set is called the cardinality set. So let me rub up this side. And also, let's look at other terms. We have the equal set. The equal set, that's number 8, right? Equal set. For instance, we have set A to be A, B, C, D. Sorry for my bracket. Make sure you write it like do it like this. Now you have it like this. So you have this first set A to be A, B, C, D, and you have the second set B to be also A, B, C, D, E, and you have the C set to be the member to be A, B, C, D. So now when we talk about equal set, when you look at this, you can see that the elements in set A and in set C are the same. Therefore, you can see that set A is equals to set B. They are called, this is equal set. But A is not equals to B. Sorry. Set A is equals to set C. Sorry, pardon me. But A is not equals to B. And also you can say that C is not equals to B. C is not equals to B. But A is equals to C. Because they both have the same elements. Right? Now, we have what we call the power set. So, this power set, you need to pay attention on this. So now, we have what we call the power set, number 9. The power set. So you have to pay attention to it. The power set, you can see that is the total let's say x. For instance, we have x to be equals to 1, 2, 3. Now, and this is, we can denote this by saying 2 raised to the power of x. This is denoted by this. For instance, now you are giving x equals to the elements 1, 2, and 3, and you have to look for the power set. These are to be the total possible set that you can form from this set given to you. That's what you mean by the power set. And you can denote it by 2 raised to the power of x. How many elements are there here? 1, 2, 3. So let's put the Cardanian symbol in front. We have 3 elements here. So we just say that 2 raised to the power of 3, which is 8. So it's starting to tell us that we have 8 subsets. And how do we get that? We can use our combination formula and also to know how we are going to write it out. But first I will explain. Now to start with all these subsets, it's going to be the first one. We have 8 subsets, so we are going to list all the 8 subsets out. You first start with your void or null set. That is your empty set. So the first one will be your empty set. Either you write it in this form or just write it like this. Just open the curly bracket. That's the first. The second one will be, you are going to write each element out one by one by saying the second subset will be 1. The third one will be other element we have 2. The fourth one will be, no need of numbering it, you can just write it straight in your book. If you are writing it in your book, no need of numbering it. I'm just writing it out so that you can see how many steps we are going to do. We have 3. The fifth one is, so now we have listed this out. We are going to be listing the set 2, 2. So it will be 1 and 2. The sixth one is going to be 2 and 3. The seventh one is going to be 1 and 3. So the eighth one is going to be 1, 2, and 3. So how do I do this? You can use your combination formula, and the way I have written it down, you can also look at it, compare it, to understand. But let's explain how to use your combination formula. Most times they will not teach you this, so I'm just teaching you to know how many you are going to write out. For here now, you can see that we write the one with 1 element 3 times. We wrote the one of 2 elements 3 times, and we wrote the one of 3 elements once, and also another void once. Now, using your combination formula, you want to do this to know how many subsets of 2 elements you are going to write out, how many subsets of 3 elements, how many subsets of 1 element you are going to write out. You can use your combination formula, which is given by m factorial over into bracket m minus r factorial multiplied by r factorial. Now, for instance, now don't forget the total elements here is 3. You are going to write 3 at the top. The combination, your r will be the number, the one we are looking for. If you want to write out the one with 1 subset, you are just going to write 1 here, and you solve it by saying 3 factorial over 3 minus 1 into bracket factorial 1 factorial. So this is because 3 factorial is represented by 3 times 2 times 1, all divided by 3 minus 1 is 2. So 2 factorial is, so I'm going to have 2 factorial. 1 factorial is 1, right? Multiplied by 1. So you can see like this cancel out this. Don't forget 1 divided by 1. You have 6 over 2 factorial is 2 times 1, which is 2. We have 3. So this one is trying to tell us that we are going to have 3 subsets containing one element. You can see that we put one here containing one element. We have one element, we have one element. You can see that it is 3 in number. 3 subsets containing one element. For the next one, we know how many elements, we know how many subsets that are going to contain 2 elements. We are going to write that 3 combination 2 to be 3 factorial over 3 minus 2 into bracket factorial multiplied by 2 factorial. So this is equals to 3 multiplied by 2 times 1 multiplied by, here we are going to subtract, you are going to have 1 factorial. 1 factorial is 1. And we have 2 factorial to be 2 times 1. Right? This cancels out this, 3 divided by 1 is 3. So what this is trying to tell us that we are going to have 3 subsets containing 2 elements. So this contains 2 elements, this contains 2 elements, this contains 3 subsets. Now, the last one that's containing 3 elements. Now we have 3 factorial divided by 3 minus 3 multiplied by 3 factorial. I hope you guys are getting along. So this is equals to, here we are going to have 3 multiplied by 2 times 1 multiplied by 3 minus 3 is 0. 0 factorial is 1. Note that 1 multiplied by 3 factorial is also 3 multiplied by 3 times 2 times 1. This cancels out this, so we have 1 divided by 1, which is 1. So it's telling us that we're going to have one subset containing 3 elements. Consider what I did. I'm just trying to tell you how to get it using your combination, how to know the number of subsets you are going to write and you know elements you're going to contain. So I hope you understand this. This is the most complex part here. Now, let's talk about number sets. So we have what's called the number sets. So I'm just going to tell you some things you should know. And here under the set, for instance, we are given a set S containing this element S such that X, let's write it down. X, yes, such that S is an integer 1 less than X less than 2. So now, what you look at, how do you write the element of S from this now? You are going to look at this and here you have delta, here you have delta. So when you want to write the element of this set S, it's going to be, you are not going to start from 1, you are going to start from 2. But in the case you have an equal to, I'm going to tell you that you get it. So now, here we are going to, when you have a less than or greater than symbol, but you are not giving, there's nothing like equals to the, you are not going to start with that number. Or for instance, there is an equals to the, you are going to end at 15. But if there is not an equals to the, you are not going to end at 15. And also, you are not going to start from 1. You are going to start from the next number, which is 2. So it will be 2, 3, 4, so on, 14. And you don't stop at 15 because you don't have an equals to sign. But for the case, for instance, you have X is equals to S such that S is an integer 1 less than or equals to S less than or equals to 6. So here you are going to list out all the elements of A. You are going to start from 1. Here we are having the equals to sign, right? We are going to have 1, 2, 3, 4, 5, and you are going to stop at 6. You also have the equals to sign. And so that's how to solve the question. And also, we have all these. For instance, we will be given that B S such that X is an odd number. So we have an infinite odd number, right? So they didn't tell us the particular place we should stop at. And just write it as B is equals to, what are odd numbers? Odd numbers are numbers that cannot be divided by 2. Since it's going to give us, going to lead to a decimal point, right? Now we have 1, we have 3, we have 5, and so on. So we have even numbers. Sometimes you may be asked about even numbers. Even numbers are numbers that can be divided by 2, right? And we have what we call the multiples. Then sometimes we give it that such that S is the multiples of 3. Multiples of 3 are numbers that 3 can divide. Like if they ask you to use the multiples of 3 now, you can say that 3 starting with 3 can divide 3, which is 1. 3 can divide 6, you have 6, you have 9, and so on like that. So let's talk about complement, union, and intersection. Those are the last parts. So another one is, I don't know the number to stop at here. Let me start with them. You have complements. The complement. Now, under this complement, for instance, you are giving your union set. Don't forget, I represent our union set with this symbol, right? I'm giving the union set to 1, 2, that's around 8. And you have your element of K set to be 2, 3, 4, 5. Now, K complement is denoted by this symbol. You can see the mark I put at the top. That means K complement. Now, what you are going to do is that you are going to subtract all these elements from the union set. What is left is your K complement. Now, for instance, don't forget we have 1, 2, so on, and 8. That is 1, 2, 3, 4, 5, 6, 7, 8. When you subtract all this from this your union set, what is left is your K complement. So it will be, when you subtract all this, you are going to have 1, 6, and 7, and 8 left, right? So this is your K complement. When you subtract K from the union set, what is left is your K complement. So K complement, you can just say that K complement is the number of elements left in the union set after subtracting the set of K. After subtracting the set of K, that's what we mean by K complement. Sometimes it may be here now we have K, right? It may be another letter. But just know that to get your complement, you are going to subtract, to get the complement of the set, you are going to subtract the set of the union set. What is left is your complement. Now we have also number 12, we have the union set. Union set. And number 13, we have the intersection. Intersection. So union of the set is denoted by this symbol. By this symbol. For instance, now you are giving set S to be equals to 1, 2, 3, 4. You are giving Y to be equals to 3, 6, 7, 9. So if they ask you to do for the union of sets, they will give you as X union Y. This is the symbol for denoting the union of the set. So this is equals to, don't forget the curly bracket. You are going to add all these sets up. That you all what is the set. You are going to combine it together. So we have 1, we are going to write 1. We have 2. We have 3. We have 4. We have 6. We have 7. We have 9. That's your, so that's your union set. Now the last one is the intersection set, and it is denoted by this symbol like this. So it is the opposite of this. Now, for instance, using the same question, you have to look for the intersection set, which is S intersect Y. So you have to look for the intersection set. What I mean by intersection set now, what you can find in the set X and what you can find in the set Y. That is the intersection set. And when you look at these elements now, you have 3 in set S and Y. Therefore, your intersection set is equals to 3. Guys, we have come to the end of the class. Please don't forget to like, share, and subscribe to my channel. Thank you.